We have example number 4 from our Master Math Mentor Lesson 40, the question on radioactive decay. So 1, 2, there's no 3, I didn't do 3, and 4. Radioactive decay is measured in terms of half-life, or the number of years for half of the atoms in radioactive material to decay. The rate of which radioactive material decays is proportional to the amount present. If 8 grams of plutonium isotope was released in the Chernobyl nuclear accident, do you guys know about Chernobyl? It was awful. How long will it decay to 1 gram? Okay, if 8 grams, that's not a lot, was released in the Chernobyl nuclear accident, how long are we going to take for it to get down to 1 gram? And its half-life is 24,360 years. So let's start with our rate. So the decay rate is going to be proportional to the amount of material that's in there. So the same thing we've been doing in all of our problems. We are going to separate the variables, and then we are going to kt plus c. We're going to solve for an equation, dot, 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 dot. You can see the other ones. You're going to get down to y is equal to some initial amount e to the negative kt. Oh, negative, right. Okay, we're in decay, so we need to have a negative, and a negative, and a negative. Got it. All right, a is the initial value. So say we had, say we just had 1 gram. We're looking for this K value. So say we had 1 gram of this material, and then we're going to get it down to a half. We're going to solve for K, but our time is going to be how long it takes. Let me shrink this down a little bit. Oh, I lost one. Our time is going to be how long it takes when the half year is 24,360 years. So now we're solving for a K value so that we can solve our differential equation. So at this point, I can take the ln of both sides, ln, and I get ln of 1/2 is equal to negative 24,360k ln of e. That's going to go to 1. And then we're going to divide both sides by 24,360. Divide both sides by negative 24,360. And my K value is going to be 2.8 times 10 to the negative 5, which is a really, really, really small value. So 2.8 times 10 to the negative 5. If I go back and I solve my differential equation, I'm going to get that y is going to equal the initial amount, 8 grams, e to the, what was my K value? Negative 2.8 times 10 to the negative 5 t. So now we're wondering how long is it going to take to decay to 1 gram? So if I fill in 1 gram here, 2.8 times 10 to the negative 5t, and divide both sides by 8, I'm going to get 0.125 is equal to e to the negative 2.8 times 10 to the negative 5t. I'm going to take the ln of both sides, ln. I'm going to get ln of 1.125 is equal to negative 2.8, 2.8 times 10 to the negative 5t, ln of e, this goes to 1. And then divide both sides by, that's a lot already, 2.8 times 10 to the negative 5. So the number that you're going to get at the end, I'm just going to move this guy, go over there. You're going to get that time, if you punch this into your calculator, is 74,000 years, 265 years. This is in years. in order for us to go from 8 grams to 1 gram. 74,000 years. Okay, that was the last example. If you have any questions or you need to go back and annotate, go through that now. Otherwise, classwork time.